folks, we are learning about the power of 10. Once again, welcome to Science with Ms. Steph, episode 67, Elephant Toothpaste to the 10th power. Hi. Yes, I'm back here again, back in the kitchen again. That should let you know that we're going to do something possibly a little on the messy side. Okay, but it's going to be fabulous. All right, welcome to Science with Ms. Steph, episode 67. We are learning about the power of 10. All right, now I do want to do a quick little clarification for those of you math folk out there who are going, she's using power of 10 the wrong way. So yeah, it's really important to understand that we are multiplying the amounts of reagents times 10, or the amount of materials times 10, right? We're comparing the difference between a particular level and then what our outcome will be. It would be or can be if we multiply by 10. Okay, all of the reagents that we're adding by 10. Okay, now as far as what to the 10th power means, that would mean that you would take the amount of reagents and you would multiply it times itself 10 times, okay? But yes, folks, we are engaging in the idea of power of 10. We're looking at exponential growth. We are coming into our 10th Summer Science Club. Yes, Summer Science Club 10, folks. Okay, it's absolutely been amazing. These past 9 years have been, like I said, just amazing. You would think that I would come up with another word, but I'm telling you, there are so many different ways that I would want to describe what it has been like to be Ms. Steph and to teach science and STEAM to all of the young people out there. I mean, it has been so cool. And I'm really thankful for everyone who has come in and has joined us via like video and all that type of stuff over this particular school year, but also folks who are saying yes to a particular call that I sent out. I sent out a request to folks who were like from back in the day, from like the original Science Club, and actually some people who've known me since before Science Club people. And I said, how has Ms. Steph Science Club impacted you? How has what the work of Triple F Empowerment Inc. like made your life better and all that kind of yada yada? Well, guess what? People have responded. There's going to be videos. You're going to get to meet Maxwell this week. Last week, you learned about Orlando and his story, and since that he's known me since he was 14. Yikes, it's been a little while. Now you're going to get to meet somebody over this next couple of weeks. Over this next week who's known me since he was 5. He's 20 now, he's in college, and his name is Maxwell, and you'll get to see parts of a little interview that I did with him over the next, like I said, week. Okay? Make sure you're following us on social media so that you can check that out. All right? Now, as far as today's science investigation, let's get right to it. I promised over on Instagram that I was going to really break it down, okay? That I was really going to explain the different things, and that I was really frankly going to do something really big and exciting. Most of the time when you've seen me do elephant toothpaste, you've seen it with yeast as the catalyst. Today, we're going to try out a different catalyst, people. We're going to rock out this stuff, potassium iodide, all right? Before I really hop in, I do want to say, please, adult supervision if you're going to attempt this one, especially if you're going to attempt with potassium iodide and with the 12% peroxide that I've got on hand and all that type of stuff. I mean, I seriously didn't upgrade for y'all because I wanted you to get to see it. But definitely, you need parents' participation and permission, and you really want to be mindful and make safe choices when attempting this particular investigation. You'll notice I will move my body back, right? I'm going to keep a distance between my eyes, beat them, and the reagents. I'm going to make sure that I'm not splashing things. Yes, you're hearing me call the chemicals reagents today because they react, right? So the things that we mix together to create or cause a reaction to happen are called reagents. It's just another name that scientists use for chemicals, okay? And in particular, things that are reactive, okay? Things that interact with each other. By the way, when I store my chemicals, yes, I have chemicals in my house. We all do, by the way, but you know what I mean. The stuff that I use for science club, that's actually what's in my pantry. I don't have food in my pantry. I have science club materials in my pantry. I am storing things that react to each other on separate levels. All right. So my peroxide and my potassium iodide, I'm not storing that on the same level. Even my yeast. You see how I have the yeast packaged up, but these are on different shelves. Okay. So, I think I've made that clear. Disclaimer and warning and whatnot, what have you. Okay. Please really take safety seriously in all of the activities that I show you, but in this one in particular, I'm really pushing that because high concentration hydrogen peroxide can hurt you. Yeah. All right. And in fact, the hydrogen peroxide that you're seeing like folks use on YouTube that makes like the huge elephant toothpaste and all that type of stuff, that is 35% hydrogen peroxide. And you'll notice that they're wearing gloves and so forth because high peroxide can burn your hand. Okay. And so when we're doing all these different things, normally I'm like doing stuff and I'm saying, hey, try it at home. Today, again, I know I'm saying it in different silly Miss Steph ways and all that type of stuff, but I really want you to be safe. I want you to have a good time. I want you to be able to enjoy your science experience. Okay? You really, really, really need to be careful. And in particular, I would say use the yeast one, okay? And use the lower percentage peroxide. But really, frankly, for cinematic, why not? I'm gonna do the cool one for y'all. Okay, all right. Cool. Let's rinse out what I've got in the sink. I'll show you really quickly what I did. This one was high concentration peroxide, but it was the yeast. Okay. Um, I used the yeast activator, or not activator, but the yeast catalyst, right? I'm actually going to put that to this side. This one over here, I'm putting it over here because it would take me quite a bit of time to rinse it out properly. All right, so putting it to the side. Okay, remember being very careful, right? And as you can see, it's actually still kind of reactive. It's so cool. Yes. Miss Steph here with episode 67 of Science with Miss Steph. Thank you for joining me for elephant toothpaste times 10. All right, now let's really get everything popping here. Am I by my sink again? Yeah. Is there a reason for that? Yeah. Because you just coming on. There's a reason I'm not doing this over by my desk. This puppy, real exciting. You know, the significant sides of the reaction. Okay, even in the ×1 reaction, you're going to see a pretty decent situation happen. All right, so first things first, we need to everything in decency and order, right? The elephant toothpaste reaction. First of all, do elephants use it to brush their teeth? No, no, no. But does it look like elephant-sized toothpaste being squeezed out of a container? Yes. So first, where does this activity or demonstration get its name? By the way that it looks. All right. If science teachers were going around saying the decomposition of hydrogen peroxide in the presence of soap and food coloring, that might not be as exciting. Granted, when I say it, I think it's fun, but it might not be as exciting for you. So years ago, okay, it got this name, okay? Elephant toothpaste. That's where the name came from. Cool, cool, cool. Now, there are different catalysts that you can use. You may have heard of sodium iodide. Again, I'm sure if you watch me, I know you know about yeast, the instant yeast, but we're going to do the potassium iodide catalyst. Same situation as the yeast. We're going to get a water going. All right. The way that I'm actually going to measure my potassium iodide is essentially kind of going almost backwards because I want a saturated solution. So I'm going to put in as much as the water can take, right? That's what we mean by saturated solution, okay? You're going to see, you're going to notice that when it comes out of the container, again, don't try some of this stuff at home. Okay? When it comes out of the container, you're going to see it as a white, this white powder, whatnot. Okay, yes, do you see the white powder? Yeah, okay. All right, that's what we've got going on here, right? Let's tilt you down. Okay, cool, 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 cool. Can you see? Can you see? Are you paying attention? Are you watching? Right? Got this white powder, and I'm just watching. I'm counting too because I know about how much should be able to go in. I'm watching how much will dissolve, okay? Also, I do kind of want to show you that the mixture is starting to turn a bit on the yellow side. That's how you know the iodine is starting to kind of react a little bit because for those of you who do not know, iodine, right, is kind of this yellowish brown. I do want you to keep that in mind when you see this reaction. I want you to tell me whether or not you notice the impact of the iodine in the reaction, if you can tell, right? If you can see the brown enough, okay? You see how I'm mixing this up, right? You see how it's still a little bit on the cloudy side. I'm going to set this to the side to let it sit. And again, you see how over here, this is still reacting. This is why for today's activity, watch me. You might not want to do it. You might not want to try. You might not want to try. The peroxide that I'm using, as I stated, is this higher concentration peroxide. It's a 12% peroxide, 4 times the amount of peroxide that's inside of, as far as 4 times the concentration, okay, of the peroxide that's inside of the stuff in the brown bottle that you get from the store. I had to order this. You did not just buy this at the store. Okay? You order this. I am going to do my smaller one first. All right, I'm going to do my smaller one first. Over here, I am also going to measure out because the smallest volume that I can measure in here is actually 50 milliliters, right? You see that I've only got a 50 milliliter line, but I want to do 200 milliliters, okay, for this. And so I'm going to come over here in the big one, my times 10 one, right? So I'm going to come over here and use my graduated cylinder so I can get an accurately measured 20 milliliters for my times 1. Okay, so my base of everything. Okay, remember I'm moving my body back, coming down to the level, pouring liquids, folks. All right, and I'm going to do 20 milliliters inside of my smaller flask. Okay, 20 milliliters of the 12% hydrogen peroxide. Okay? Remember, this is our times 1 situation. So I'm only going to do just a little bit. Is a little bit of sweat? Just a little bit. Oh, yes, of this soap. Without this soap, this thing really doesn't look very exciting, I'm telling you. All right? It looks a little on the boring side because it doesn't look boring, it's exciting. But the bubbles are not captured. Remember, to capture the bubbles, we need the soap. That's one of the things that surfactants can do. They have a lot of other superpowers, but to capture the gas produced in this reaction, we definitely want the bubbles. Alrighty then, and now we're adding food coloring. We're going to go ahead and see if we can get some stripes going. So you're going to see me add food coloring down the side. All right, I did blue and now I'm doing this pink situation. Remember, you're supposed to keep an eye out to see if you notice an impact on the color and on just how the reaction looks when I add my potassium iodide with solution anyway. This potassium iodide is not in solid form, right? All right, let's move you. I'm going to tilt you so that you're not looking at whatever's back there. All right, so now, again, I'm going to measure this. I want to use I want to use 10 milliliters, okay, of potassium iodide. You see it? It's looking a little yellow. Do you see it? So I'm, again, coming down to a level, keeping my body back, making sure that I'm not splashing this, okay? This is remember, this is my catalyst. My catalyst. But Miss Steph, what does a catalyst do and why do we care and why does that matter? A catalyst makes something move faster. The majority of the reactions occurring in our bodies, okay, involve catalysts because a lot of the reactions just happen at their natural pace, which is like slow. And a lot of the reactions in our body need to happen like faster. So we have catalysts inside of our bodies to make things go faster. The reaction that's happening with the hydrogen peroxide in this situation, right, is one of the oxygens, right? Because you have your H2O2. Okay, H2, you should be able to see it, H2O2. So it's essentially water with an extra oxygen. So we as scientists are going to use our special superpower, which is like knowing science, okay, to take that oxygen off. And once we take it off, we want to be able to see it. We want to be able to see whether it looks cool or not. And so the soap and the food coloring will help us see the reaction and see the bubbles and all that kind of happen. Again, the catalyst helps things move faster. So it helps that oxygen come off faster. Because if you leave the cap off of any bottle of hydrogen peroxide, the oxygen is like coming off slowly, just at its own little pace. Eventually it just will come off. But today, we as scientists, we want to control how much comes off, and we want to see it come off faster. Now, so I'm adding 10 milliliters, right? Remember, the theme of May is to see if adding a 0, if multiplying something times 10 is more powerful, if it will change the size, the magnitude of our reaction, the magnitude of our impact. Yay! See it. Isn't that cool? But you're saying to me, Miss Steph, it's a little far away. Get us closer. Oh, I'll get you closer, honey. I'll get you closer. Isn't that cool? Do you see the stripes? We created some stripes. And oh, do you see? Does that look a little green? But did we put green in? I don't think so. I think the green is a result of the yellowish tint that we get from the iodide. Yellow and green make blue. We know that. Do you see? First of all, I want you to really realize how large and how amazing and how prolific this reaction is, even though it's in this little itty bitty flask, and even though I use 20 milliliters of my 12% hydrogen peroxide plus 10 honey, little itty bit, 10 milliliters of my potassium iodide mixture, my potassium iodide solution. And off of this, it's having this reaction because it's so hot. It is an exothermic reaction. You'll notice I'm not going to touch it with my hands. It's still going. In total, if you think about it, if you add 10 plus 20, my mathematicians out there, 10 plus 20, that's only 30 milliliters. I only put 30 milliliters of reagents in there. Plus, the little bit of soap that I put in there. And it's still giving me this significant of a reaction. Ooh, child. Who is excited and who wants to see what's going to happen with 10 times that amount? Think about it. 10 times that amount. 30 times 10, right? 300 milliliters of reagents together. Wonder what that's going to do. Let's put our hypothesis down in the chat while I set up, okay? Because I need to set it up, right? You saw what I did before. I need to do the same thing, okay? This is not one of those like YouTube situations where like all of a sudden where I'm putting in reagents that I'm not telling you about, I promise, okay? I need to do the same thing, but I'm just going to do it times 10. Remember, that's our theme. Times 10. I'm showing you what happens in a reaction when I multiply the reagents, the amount of those reagents times 10. Okay? So, as far as the measurements, we're learning a lot about measurement this month. May for measurement in May. All right, so I'm going to go 200 milliliters. Okay, 200 milliliters of my, what? Hydrogen peroxide, right? So I need 200 milliliters of my hydrogen peroxide to go inside of my flask. Okay? 200 milliliters of my 12% hydrogen peroxide. Again, I'm trying to be very careful when I'm moving these about. Taking that out. Okay? Those of you just joining me, welcome to Science with Miss Steph. Folks, we are here and we are hanging out. Science with Miss Steph, and I am doing a theme for the month of May. I'm showing you what happens when I multiply what we're putting inside of things times 10. All right? So we just did our times 1 situation. Now I'm going to do my times 10. Should you be dancing like that in the laboratory? No. Be real careful. All right, so showing you again, let's tilt you back down. I'm going to do this pretty quickly without a lot of chitter chatter, okay? Because one, we're coming to the end of our time. And two, you probably really just want to see what happens at this point. I mean, I would if I were you. Like, I would just want to see what's going on. All right? So, holding. I'm going to tilt you. All right, coming down. I'm going to put 200 milliliters of my 12% hydrogen peroxide. That's 4 times the potency of the hydrogen peroxide that you see in the brown container. You notice how strong that container is? All right. We are using potassium iodide as our catalyst. Potassium iodide clearly is a bit of a stronger, more effective catalyst for this particular reaction. Let's go ahead and put down our balloon. Okay. And I'm going to do it the same way. I'm putting it down the side. Okay. My food coloring is running out, folks. But that's okay. My food coloring is running out. Remember, or rather just FYI, if you're just coming on and joining us, okay? First of all, thank you. Miss Steph here for Science with Miss Steph. Welcome to our Saturday series. A couple of things that we've got coming up. People are going to be, we've got in-person stuff coming up and whatnot. So just know we've got some changes coming up. Notice I'm going to add a significant squeeze of my soap because I'm adding 10 times that. The only thing I did not multiply it times 10 obviously was that food coloring because my food coloring is running low. Okay. I am going to add 10 times more of this than I added to the other situation. 10 times more of this. I used 10. I say 10. I used 10. Say it again with me. 10. I used 10 milliliters in this setup, which means I need to multiply times 10. Easiest way to multiply times 10 once you have a clarity on the concept is to drop a 0 behind it. So I'm going from 10 milliliters to 100 milliliters. I'm pouring relatively quickly, but notice I'm moving my face back. I'm set really far back. And I'm measuring up to 10 times 10, which is 100, which also happens to be 10 squared. 10 times itself. When you're squaring things, you are multiplying something times itself. All right, so down in here, I have my primary reagent to this particular reaction, okay? Primary reagent, right, meaning my hydrogen peroxide. And again, I'm using 12% hydrogen peroxide. Please be careful if you're going to try this at home. I am not giving you permission to do it at home without parent permission as well as parent supervision. Parents, if you want to try this with your young scientists at home, go for it, but really make sure you're being extra careful. I have hydrogen peroxide, a really significant squeeze of dish soap, clear dish soap. Y'all know I like clear dish soap because, well, I mean, it doesn't impact the color. I have 100 milliliters. It's looking a little shy of 100, but 100 milliliters of my potassium iodide reagent in here. And then I have my, as you can see, my food coloring, trying to see if we can get that strike action to happen one more time. I'm going to move it over here and pour. Remember, you're supposed to tell me whether or not you notice an impact on the color from the potassium iodide. I mean, I do. I don't know about y'all. Right? Y'all see how big this reaction is. the magnitude of the reaction is quite significantly larger when I use 300 milliliters total of reagent. Well, actually, it's probably more like 350 by the time you add in this, the amount of soap that I added. I mean, it looks cool, people. And do we see what's happening on the edge here? That is because this is an exothermic reaction. It pushes off heat. I'm feeling it. It's warm. And we did get our stripe. Yay! Fun! But a lot of my foam, a lot of the foam has kind of a bit of a yellowish tint. That is because of the particular catalyst that I used. I used potassium iodide. Okay, potassium iodide solution. I have seen it where people just like add like potassium iodide, like the solid powder that I showed y'all in there. I'm not a big fan of that. I think you got to be careful with that. It's a little harder to control a solid to, get it all the way in there, but okay. Once again, you see how big this reaction is, and not only how big it is, but how much faster it is. Yes, 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 yes. How much faster it is, okay, than the yeast reaction. The yeast kind of just keeps kind of bubbling over. All right, who wants to see, okay, for comparison, before we go, okay? Notice I'm trying not to touch my face because that's not safe. Okay? For comparison before we go, who wants to see my yeast catalyst? My yeast soap and food coloring mixture. Okay. All right. In the graduated cylinder with my higher concentration. Can't you tell I want to see it because I'm about to do it? With my higher concentration of peroxide. I think we should do that before we log out. I'm not offering to mix catalysts. Not what I'm offering to do. What I'm saying is that I'm going to log out and finish, or not log out, but I'm going to close out with using the higher concentration of my peroxide and my yeast catalyst with y'all right here on Facebook. Now, my folks over on Instagram already saw the yeast catalyst with the higher concentration of peroxide. They already got to see that and to see what happened. Okay? So this is me just doing a little something for you over here on Facebook. Okay? And eventually YouTube. My YouTube people, hi. Okay. This is a 250 milliliter graduated cylinder. Okay. The other thing I want you to really observe, watch me, really observe if the shape, okay, of the foam shifts, right? You notice how the foam kind of moved and swirled around when it came out of the flask? I wonder if that will happen with the graduated cylinder. Okay, this is a 250 milliliter graduated cylinder. I'm going to come down and come back. I want to see. I'm going to actually go ahead and use the rest of this bottle, which is, believe it or not, right at 100 milliliters. Okay. Before recycling, yes, this is a tube. Okay, so this gets recycled within the U.S. Why not put it in the recycling? Before recycling, I will fully rinse that out because, as we've found out, it should be very clear to you how reactive hydrogen peroxide is. Okay, at this point. Once again, this is my catalyst that I used over on Instagram. This is warm water. Okay, instant yeast, about 4 scoops, and 2 different colors of food coloring, as well as soap. So when I did it over on Instagram, I pretty much did everything together, okay, except for the peroxide. Cool. So let me tilt you. Let's see. All right, folks. And this is how we're closing out our adventure today. Okay. You can see that this reaction has come to a close. All right. Okay, I'm gonna move it over a bit, but I don't want to pull it out of the sink because again, the sink is kind of helping contain things. This is pretty much going to start reacting as soon as I add it. So let's use, this is my same graduated cylinder that I used earlier. I'm going to go all the way up to 50. Again, I'm not mixing my catalyst in the same container. I am letting you see my yeast catalyst from my Instagram adventure earlier, okay, with my high potency peroxide in the graduated cylinder. Let's see what that looks like. Let's see if anything happens. Boom. Okay. Do you notice a difference in the shape of the foam, in the thickness of the foam, in the speed at which the foam is coming out of the container, and the magnitude of the foam? Doesn't that look like way less foam? Oh, your catalyst, as well as the potency of the peroxide, impacts how the elephant toothpaste eventually turns out. I strongly, highly, extremely recommend using yeast catalyst when trying this at home. Okay? Because it can still be just as cool, right? We've learned that. We know it's just as cool. Okay? We also know it's a bit safer. Okay? Let me show this to you one more time. Here's your close-up. Here's your close-up. Here's your close-up. Hopefully I'm getting the right angle. Okay? Once again, for those of you who are just now coming on and are thinking to yourself, why is Miss Steph in her kitchen today? This is why. So that you could see the full magnitude of the reactions, okay? As well as keep my home not being messy, okay? All right, folks, that's it for today. I think we had a real good time. We got to learn quite a bit, right? We learned about the impact of multiplying the amount of reagents times 10. We also learned, frankly, that different catalysts have different magnitudes, right? That you can get a larger reaction. You can get really that elephant toothpaste swirl when using the potassium iodide. Okay, am I recommending trying this at home? No, I recommend watching this video, okay, for the fun. All right, so it's been fun. We have several events coming up. I'm going to drop the links down below when I upload this to y'all over on YouTube. I will drop the links down below as well. Please make sure that you are commenting and sharing and showing us love for our exponential growth campaign. All right. Shout out to the Science Club community. I look forward to seeing you next week. Next week, we're going to do an oldie but goodie, and you'll get to see how much of an impact multiplying times 10 can make. Thank you, thank you, thank you. Yes, I say it too much. I don't care. I will say thank you as much as I can. As long as I can fix my mouth to say it, I will say thank you. Have a wonderful and blessed day, folks. Until next time. Thank you for watching Science with Ms. Steph. We hope that you will subscribe to the YouTube page. Hello. Click follow on the Facebook page. Yes, yes. And definitely hop over to either our Facebook exponential growth campaign or all the way over to Give a Lively to check out how you can use your power of 10 to help us inspire even more children to go into the sciences. this summer.